Did you know there are volcanoes out there so big they're called supervolcanoes? These humongous volcanoes can blow their tops with more than 1,000 times the force of the atomic bomb dropped on Hiroshima. So what's a volcano to do when it wants to blow its top, but also not blow its top because that would be bad? Well, supervolcanoes have found a way. They blow their tops little by little over long periods of time, releasing pressure gradually instead of all at once. And we're about to find out how. This is my channel. There are over 30 locations around the world where massive ancient eruptions have left behind colossal calderas, which are essentially just giant craters. But only a few of these places are actually active volcanoes, meaning they could blow again. And of those, only a handful have been doing just that, slowly but surely releasing their pent-up pressure in ways that could help scientists better predict when other supervolcanoes might do the same. A volcano might start off as a small, seemingly insignificant mound. But if it has magma coming from deep within the earth that's willing to go the distance, it can keep growing until it's a massive structure over 2,000 feet tall. And while many volcanoes form in chains, there are some lone wolves like Mauna Loa in Hawaii, which formed far away from any other volcanoes. The reason why this mountain grew so big is related to why it and other massive volcanoes like it are so dangerous. Unlike most volcanoes, which are built up of layers of lava flows, ash and rock, supervolcanoes have magma chambers that are much deeper and connect to magma plumes that reach deep into the Earth's mantle. Some of these giant magma chambers hold enough magma to fill up Lake Ontario. When that much hot rock is waiting below your feet, the pressure can build up enough to blow the volcano's roof off, sending a pyroclastic flow across the landscape like a giant wave. And this kind of eruption is known as a Plinian eruption, named after Pliny the Younger, who described the eruption of Mount Vesuvius that destroyed the Roman city of Pompeii. The smaller the volcano and the thicker the magma, the more likely it is to have a steep-sided conical shape. But the larger the volcano and the thinner the magma, the more likely it is to have a huge flat caldera. The largest known eruption in history was the 1883 eruption of Krakatoa, an Indonesian volcano that blew its top with about 200,000 times the force of the Hiroshima atomic bomb. It sent rocks and ash more than 10 miles up through the air and generated a tsunami that killed more than 36,000 people. Now imagine something twice as big. That's about how powerful the supervolcano at Yellowstone National Park erupted about 640,000 years ago, flinging ash over much of North America. Eruptions that size don't happen every day. In fact, there's no record of them happening in the last 2 million years. But a new study says that at least one supervolcano has managed to do exactly that, erupting 26 times during the Pleistocene epoch, which lasted from about 2.6 million to 11,700 years ago. Even though there are no written records of these events, scientists were able to reconstruct the history of Taupo volcanic zone in New Zealand by looking at the geologic evidence, including at least 26 tephra layers, which are deposits of volcanic ash that formed during individual eruptions. One of these layers dated back to about 1.35 million years ago. And this eruption alone covered nearly 3,000 square miles with a layer of ash about 6 inches thick. For comparison, the most recent eruption of Mount St. Noggins in Washington state happened in 1980 and covered about 200 square miles with less than half an inch of ash. So yeah, these ancient eruptions were pretty big, but even though they happened a long time ago, scientists still think they can teach us something about what might happen tomorrow. That's because, unlike their short-lived cousins, the normal kinds of volcanoes, supervolcanoes have found a way to stay active for hundreds of thousands of years. A study published earlier this year suggests that instead of blowing their tops all at once, some supervolcanoes release pressure more gradually through a process known as Mush Extrusion. Now, you might think all volcanic eruptions look alike, but there are actually different types of eruptions based on what's coming out of the volcano and how fast it's coming out. Plinian eruptions involve explosive blasts of gas and ash that shoot upward, but there are also effusive eruptions that are more like lava lamps, where magma oozes out of the volcano without an explosion. Mush extrusion is a combination of the two. Instead of being runny like lava, the magma is stiff and gooey like peanut butter, so it slowly extrudes or squeezes out of the volcano. This process happens over hundreds to thousands of years, and it releases the pressure inside the magma chamber more gradually. And while this is great news for anyone nearby who doesn't want to get covered in ash, it also helps explain how supervolcanoes can erupt repeatedly without completely destroying themselves. Like if a volcano blows its top, it's done for. But if it can release pressure gradually, then it can keep on keeping on. To figure out how mush extrusion works, scientists turned to an unlikely source: ice cream. Specifically, they looked at a type of ice cream that's commonly found in grocery stores. In Japan, this treat is known as soft serve, and it's made from a stiffening agent called guar gum. This makes the ice cream harder to scoop, but it also shares some similarities with the magma that's found beneath supervolcanoes. Using a device known as a rheometer, researchers applied stress to samples of ice cream while measuring how the samples flowed. They wanted to see if they could model how magma moves under pressure. What they found was that in order for the ice cream to flow, the amount of stress placed on it had to be higher than a critical threshold. Once the stress exceeded that threshold, the ice cream started flowing immediately. Their results suggest that magma does something similar, which means that if the pressure gets high enough, it will burst out of a volcano right away. But if the pressure rises more gradually, the magma will eventually find a way to squeeze out of the volcano. In fact, scientists now think that mush extrusion is the main way magma gets out of a supervolcano, at least in the times leading up to major explosive eruptions. To date, they've found evidence of it at 5 active supervolcanoes, 4 in New Zealand and 1 in Indonesia. What's more, scientists think this process may also explain the formation of calderas. As magma chambers get emptied out, they collapse, leaving behind a crater. But in some cases, that crater is filled with water and becomes a lake. And in other cases, it doesn't collapse at all. Scientists think this is because of the type of rock that lines the magma chamber. If the walls are stiff, like in some supervolcanoes, they can support the weight of the magma above them and keep the chamber inflated like a balloon. And if they break through the roof of the magma chamber, that would result in a sudden explosive eruption. But if they don't break through, the magma can be extruded more gradually, and the supervolcano can keep calm. Now, scientists are still working to confirm that mush extrusion is actually happening at these volcanoes. But if it is, it could help them develop better models of how supervolcanoes work, and possibly even predict when they might blow. It turns out knowing how a volcano behaves when it's not quite ready to blow, its top could help us better understand what it's like when it really lets loose. So if you ever find yourself near a volcano, don't worry too much about getting gooed. Just try to keep your eyes on the prize. Don't stare directly at the sun. Okay, thanks for watching this episode. We've made thousands of educational videos over the years, and we've been able to offer them for free because of our patrons. So to all of our patrons, thank you for what you do to make this happen. If you're not a patron, but you want to learn more about what that means, you can go to our support page.